Hello everyone, my name is J1. Very glad to be here to present our work TimberTrek, exploring and creating decision trees with interactive realizations. This is joint work with Treaty John, Racing, Takuya Takaki, Zhichun, Polo Chao, Sensor Rooting, and Margot Seltzer. As we all know, over the past decade we have seen a booming of machine models. However, most of the models are black box models, meaning that people do not understand how they make predictions. In high-stake domains such as finance, healthcare, and criminal justice, people really prefer interpretable models. In particular, people really like sparse decision trees. So what is sparse decision trees? Decision tree is a very classic machine learning model. So after training the model, we have a tree structure for the model. So each node is an if statement for one feature, and the branch depends on the condition of that feature. And the leaf nodes of the decision tree is the prediction. For example, here is an example of binary classification of loan approval prediction. Here the plus sign means approval and the minus sign means rejection. And the decision tree is sparse if it is not too tall. For example, we have only 4 to 5 levels, that we call it the sparse decision tree. People take sparse decision tree because they're accurate. From 2 years ago, researchers have introduced a new breakthrough optimization method, and they show using the optimization method, the decision tree is as performative as black box models. And decision trees are very interpretable, so they're very easy to understand. Also, the decision trees are very simple, so decision rules can even be memorized by the domain experts in high-stake domains. And in practice, we have seen there is a problem that people can see there are multiple good trees. For example, we can see multiple trees that look very different, but they will have the same similar accuracy. People call this like Rashomon effect. So the idea of Rashomon effect means like the different description of the same incident. So maybe I've heard of a story before. So one man required many people to come up to touch an elephant without seeing the elephant, and let them guess what object they are touching. And based on the parts people are touching, they have different guesses. And those guesses are the faithful guesses for the elephant, even though not elephant. And the same phenomenon exists in machine learning. That means like we have multiple good models. Because the complex world is very hard to model the complex world perfectly. So we can see that multiple decision trees have similar accuracy, but they look very different. And people call then those set of good, equally well-performing models as a Rashomon set. And the Rashomon set can be very large, so we have more than 3 decision trees. More recently, research have shown that Rashomon set of decision trees is actually huge. There can be more than 1,000 decision trees that have very similar accuracies. And the phenomenon really poses a new challenge, is how can we tell the users which tree to use? And the problem can be solved by better organize the decision trees in the Rashomon set. For example, let's look at one decision trees. So here we have a binary classification decision trees, so we can linearize decision tree into different decision rules. For example, we can track the decision rules from the root of the decision tree to the leaves of the decision tree. So we have 4 decision rules. Those 4 decision rules perfectly summarize or categorize the decision tree. So we have all the information that tree consists. So we can repeat the process to all the different decision trees and track their decision rules. So here we have probably like 4,000 decision rules. The problem becomes how do we summarize those decision rules? One way is to use a radio layout to summarize and visualize those decision rules to save some space. And because here we have 4,000 decision rules, we can use an abstraction to group and sort the different features together and also group them together. So we have a donut chart for one level, and we repeat the same for different level. We have another donut chart, another donut chart. Eventually, this chart becomes a sunburst. And by leveraging using sunbursts to visualize the Rashomon set of decision rules, we design and develop TimberTrek, the first visualization tool to help users to curate and explore decision trees. And our tool is open source and we have public demo. You can visit the demo using the link in the slides. Next, I will give a short demo of this tool. In the demo, we'll use risk different prediction. So here we want to do a binary classification to predict a person will reoffend in 2 years. And the feature we use includes age, sex, prior crime, and other features. When user opens the tool, they can see a sunburst overview in the middle of the tool, and we use a different color to encode different features. For continuous feature, like number of prior crimes, the blue here, we use different lightness to encode the ranges of that feature. User can hover over different arcs to see the name of that features. User can also click one arc to zoom into that feature. What it does is to only show the trees that are using the specific feature at a specific level. User can also repeat the same for different level. User can hover over different gray arcs to see all the decision trees following that decision path. For example, here is a blue to green. And the user can click one gray arc to pin the decision tree. You will open a tree window on the left side. User can also zoom in and zoom out of the sunburst chart. User can click in the middle to go back to the original layout. We can find a different trace here. So for example, here we click age less than 21, and prior crime greater than 3, and junior crime equals 0. So maybe this tree looks interesting, so we can pin this tree as well. So user can drag around different tree windows so they can lay out them so they can compare different trees side by side. User can also click the scale by sample size button. So what it does to change the rectangle width to represent the sample of the training data that fall into that condition to help a user know how balanced the tree it is, and the user prefers a balanced tree. So here we can see the first tree is more balanced, so we will favorite that tree. To do that, we can click the heart button so to save the tree into the favorite panel. We can also write a comment to document some rationale, so why we choose that tree as the favorite trees. Okay, so let's go back. Another feature they can use the search panel. So for example, here I click the search panel, so we can drag the slider to filter the trees by their accuracies, or filter the trees by the minimum leaf samples, the number of samples in the leaf nodes, or by the tree heights. User can also filter the different decision trees based on the features the trees are using. For example, we can just uncheck different features, so all the trees are gone in the Sunburst overview. We can also choose a feature that uses a particular level. For example, here we turn off all the prior crime in the first level. So imagine we are a user, so we want to find a fair trees. So here we just uncheck all the age and sex because they are protected attributes. We also filter the trees by the minimum leaf samples, so we can see what the trees left. So this is interesting trees. So here we can see the accuracy is very high and also very balanced, so it's a very good tree. We can save the tree into the favorite panel and also leave a comment for the tree. Finally, user can click the favorite panel and export the saved trees. The saved tree will be a JSON file that a user can use in their Python package. To support the workflow of different data scientists, TimberTrek also supports computational notebooks. So a user can just call out the Python package for TimberTrek, and they can see the visualization directly in different types of computational notebook environments. And to create notebook widgets, we apply a simple method called Nova, which is a simple method to create notebook-ready visual analytics. And this work is also accepted as a poster for VIS'2022. So if you have any questions, please come to see the poster and talk to me. And the limitation of TimberTrek includes the limitation of number of colors. So if there are too many features, we might run out of colors. Also, the tool only supports binary classification right now. And for future work, we will plan to run a user study to see how the people use TimberTrek and what kind of tree will they select and curate. And that's all. Thank you so much for your attention, and please try out the tool by visiting the link in the screen. Thank you.